Hi, in this video I would like to solve a very important function in mathematics called the sinc function. The sinc function is expressed as the ratio of the sine of an angle divided by the angle. So sine theta divided by theta is usually expressed as sinc of theta, and this is mostly used in engineering problems. So what is the value of the limit of sine theta divided by theta as theta approaches 0? It's well known that this limit is equal to 1. But how do we solve it using calculus techniques? Now, if you do a direct substitution of the value 0 in the sinc function, so what we get is the limit as theta approaches 0 of sine theta divided by theta. Direct substitution will lead to sine 0 divided by 0, and sine 0 is 0 divided by 0, so this is an undetermined case. So for those who have no advanced experience in calculus, how would we solve that? There are many ways to do it. Either use the Maclaurin series or using the L'Hopital rule. But in case that you don't know these rules, what is the alternative way of solving this kind of problem? Because using mathematics, using the regular and typical math tricks will not allow us to solve this problem easily. So in this case, we need to rely on another way, such as geometry. So let's discuss this in more details. So let's first sketch the unit circle. And we know that if you have an angle theta, and this point is on the unit circle, so the radius of this circle is 1, we know that this point is on the xy plane, and this point is represented by the coordinate x, which is cosine theta, the coordinate y, which is sine theta. Alright, so we know that this point represents x and this is y, so this is cosine theta, and this point is sine theta. So sine theta represents this height. So from here to here is sine theta, that distance. So in this question we have theta approaches 0. So this means that this line or this angle is moving as theta approaches 0, then this point is moving close to the x-axis. So if you zoom in, you would see that this angle is approaching this at this position. So here, if you look carefully, we can approximate this shape, or the closed shape made from these sides, by a small right triangle. Okay, so let's see that this line is the radius, which has a length equal to 1. And we know that this line represents cosine theta, and this line represents sine theta, the height. However, if we look carefully, this is just the arc length. All right, of when the radius is 1 and the angle is theta. So we know that the arc length is equal to r times theta. So if the height is represented also by sine theta, so when theta is so small, close to 0, we know that the arc length is equal to sine theta. So if you go back, if you draw the sketch, the triangle, this small triangle, now we said that this is sine theta, and at the same time it represents the arc length, which is equal to r theta, which is just equal to theta. So theta equal to sine theta. So now we have shown that when the limit of theta approaches 0, sine theta divided by theta is equal to the limit as theta approaches 0. Sine theta as theta approaches 0 is basically equal to theta and divided by theta. This theta with theta cancels out, and the answer is equal to limit of 1, which is 1. And that's conclude the proof. Consider now the following example. Let's evaluate the limit as theta approaches 0 of sine 3 theta divided by theta. How do we do that? So we can use the idea of substitution first. Phi equal to 3 theta. In this case, we have theta equal to phi divided by 3. Now, when theta approaches 0, it's clear that phi also approaches 0. So 3 times 0 is 0. So in this case, we can express the limit as 5. Phi approaches 0 of sine phi, and theta is replaced by phi divided by 3, which is equal now. So what happens, remember, if I have a fraction a over b divided by c over d, this is expressed as a over b multiplied by the reciprocal of the fraction in the denominator. So in this case, this is equal to the limit of phi approaches 0 sine phi, that's the first fraction, divided by 1, of course, multiplied by the reciprocal of the denominator. If you continue, this will be equal to the limit as phi approaches 0, 3 times sine phi divided by phi. I combine them together, and then the constants can go out of the limit. And we know that this is just equal to 1. So the answer will be 3 times 1, which is equal to 3. And that's it.